Hello and welcome to this live coding session presented by Java User Group Oberpfalz. Thank you very much for joining. I am your host, Johannes Rabauer, and today my guest is Bartolomeo Sorrentino, creator and maintainer of LangGraph4j. And we'll try to pin down exactly where LangChain4j tool calling loops stop being enough, and then build a train delay watching agent. And we'll see if that is a good use case for it, and try to implement LangGraph4j. So as always, this is live and unscripted, so expect mistakes, many mistakes now. Expect mistakes, but learning is pretty much guaranteed. And please ask questions or state doubts, but really any kind of feedback is always greatly appreciated. So let's welcome together Bartolomeo Sorrentino to the stage. Give me 1 second. Oh no, this was badly timed. Hi, Bartolomeo.
Hi, Johannes.
Great to have you here. How are you?
Thank you for invitation.
Well, thank you for joining. And today we want to talk about LangGraph4j, but first, a little bit about you. You are the creator and maintainer of LangGraph4j, but in your main business, you are a principal software architect and CTO of Softphone SRL, right?
Yes. And I'm working in IT from the 30 year, and now a long time, And in my experience, the main business that I'm involved has been as a solution architect in large enterprise. And now I'm working in Softphone AI this is involved in a business about CTI call center that connect with CRM. And the principal in the moving of this AI wave, the company are moving toward the conversational AI. That is the objective, and also to build MCP gateway and so on. And in my experience, I've started a long time, so I've seen the different age of the IT, also before network and before internet. Yeah. And in my experience, forced me to moving on, and in this era of the IT. And now we are in AI era, and the LangGraph4j is one I have started also to deal with the experience and gather feedback from the community around this kind of the topics. Yeah. And I've joined the community, the open source community, a long time ago, because I love to share knowledge. In my soul, there is an evangelist that won't share, because share is the best to improve also myself. Sharing and collaboration is the focus.
Absolutely.
It's very important. And open source helped me in this. Also for LangGraph, that now there are a lot of contribution, and I've seen that also in some article happen on LangGraph. I'm surprised of that, and I'm glad that someone started to have interest in my project. And Johan, I want to tell you the history behind the starting of LangGraph4j.
Yes, please. Absolutely.
Okay. Yeah. I can start?
Yeah, go ahead. That's why we're here, to find out why you would even need LangGraph4j and what this is all about.
There is a little history behind the LangGraph4j, because when AI was unveiled from OpenAI, I started as solution architect. I very interesting. I understood that there was a new era inside the IT, and I started to try to understand. I have subscribed OpenAI, in particular the API, a lot of I've started to understand. And one of the first framework that appeared in that period was LangChain Python. That was an incredible library for me, that I started to learn Python and work on the LangChain. After the work in LangChain, I tried to apply this with the POC in my company and in the customer that asked for understand what is AI. And LangChain, during this period, started to build LangGraph. LangGraph for me has been, it's incredible. LangGraph, Python version, the original from LangChain for .ai company, LangGraph for me was a revelation. So because LangGraph gave to me the control and predictability was I always need inside the enterprise process. So I started to work on that, and happened that one customer asked me to build a complex workflow using AI. But they said me, I have an IT that based on Java, and so I want to continue to work on Java. So you have to build this kind of the task using Java. And I started to search on internet, but there is something similar to LangChain or LangGraph, and I found out LangGraph4j. So okay, we arrived at, I'm so close to the final solution, but nothing about LangGraph. So I started to say, okay, I want to build something similar to LangGraph Python and join this with LangChain4j. Why this, Joan? Because in my experience, I remember the brand of Java that said, write once and run everywhere.
Yeah,
In my
yeah,
experience,
exactly.
okay, this is a famous, very famous brand. But in my experience, as developer, as architect, I think that now is most important, write once and apply everywhere. So learn once, sorry, and apply everywhere. So it's most important. Learn once means you have to learn approach, you have to learn pattern, you have to learn environment, and apply this in every environment, in every context that you have to deal. And in particular, it's very important to learn a paradigm, and you like a pattern that you have a solution in a context, and you can move this solution also in different contexts with different programming language, because the problems are the same.
Okay, let me try to summarize just quickly. So you worked with LangChain, and then you went ahead and discovered LangGraph, and you thought that's a nice idea, and then you looked for it if there is possibility. No, the same system on Java. You didn't find one, but you found LangGraph4j, which is also a pretty, well, now at least, it's a pretty big project. But you did not find any LangGraph in there. So they did not implement this. And so you thought, well, let's build it yourself, because it's a good approach, and you only want to learn this approach once and apply it everywhere, for example, here in Java.
I want to confirm this because I've started also, I've developed a couple of the iOS application. I've also developed the LangGraph for Swift, also to apply the same approach also on iOS.
Okay.
So now it's not a big project, LangGraph for Swift, but I have applied it. And when I started with the first implementation of LangGraph4j, I've opened an issue with on the LangChain project, LangChain4j project, and say I have built this first release of LangGraph. Do you have interest in this? Because my idea, my dream, was to join LangGraph inside the LangChain4j in the same stream, because as you said, now it's a huge project, but at the time was just at the beginning. But they answered me that agentic workflow was the brand that I have put at the beginning. They say, agentic workflow at that time is not our focus. So it's interesting the project, but we don't want that you put your work inside our stream. So right. I have okay, I have a bit sad of that, but I have continued on LangGraph4j, and I have followed the mainstream from Python, and I've replicated the main feature from Python, and I've started to apply in production. And because a lot of customers to open production of the AI was scared, so we have started a lot of POC and using Java and with the LangGraph, and suddenly I have had a lot of contribution, a lot of pull request, a lot of the discussion. I'm surprised of that, and I've understood that Alibaba framework, agentic framework from Alibaba, have adopted LangGraph4j as a foundation of their framework. So a lot of the question and discussion was by developer of Alibaba that asked me to implement some feature or to, what do you think about this? What do you think about that? And unfortunately, Alibaba have extracted and embedded the LangGraph inside so it's not follow mainstream. But the contribution have increased the visibility, and also the software have built a lot of things, and I will continue to apply. And the problem with the LangGraph, not the problem. I have keep the LangGraph agnostic, so non-opinionated about LangChain4j and Spring AI, because every Java developer knows Spring as a foundation of a lot of application in Java. Spring is everywhere. And so after LangChain4j started Spring AI, and I choose to say, okay, I don't want opinionate, I don't want to join too much LangGraph with the LangChain4j, but also Spring AI. This helped the framework to be agnostic, and also the solution will be different, because in order to maintain the compatibility, I've find out a lot of the trade-off on that. And now the problem with LangGraph, and I think that the LangGraph solve a particular problem. And I've seen that in AI, the evolution is, and the first evolution was the prompt engineering. Everyone goes toward the prompt engineering. I write the best prompt. I want the prompt, the lean prompt that solve more problem. And after, I have seen the loop engineering. So a lot of other, because aside the prompt, arrive at the harness, because the real meaning, the real powerful of the agent are the harness. So all the infrastructure around the model. And now I've seen the rise of the graph engineering. That is perfectly what LangGraph do. So create something that you can control. But everyone, I have a lot of the discussion with the contributor of the LangGraph4j that say, okay, I can do a lot of things with the Anthropic model, with OpenAI, with the agent SDK and so on, right? But everyone are focused to create a biggest agent that solve everything.
Yeah.
LangGraph is not in that direction. LangGraph look the real enterprise problem to move the workflow that are put in place now in the enterprise in the AI fashion. So to put the process, to put inside the process of the enterprise, the smartness of the AI. But the problem is if you don't control, if you give all the possibility inside the loop, inside the 1,000 agents that dynamically spawn and solve a thousand of a problem, who control this? Just the result. And if when I have built some financial workflow, but it's not the customer don't understand. So the loop start, a lot of agents start, and after they call tool and do something, and after that, I want control every step. I want to also to understand which step the process inside this step. And LangGraph do this. You have to create a workflow, and it's not LangGraph I don't propose that every step is powered by AI, but not every step. There are steps that are powered by AI and steps that are just technical for control or for calling API, because it's not, in my opinion, you can call API not, you can delegate the calling API using tool MCP to the agent, but you can also call API in a technical way because you could have a integration problem. Integration problem means a rollback. If I have to contact three systems, I have to do rollback. To explain the rollback concept to an agent is a very huge task. But you are already have the code for rollback. You can put AI agent that do something and the code that handle rollback feature, for example.
But, okay, but Bartolomeo, just to clarify again. So, as a simple example, so in LangGraph4j, you can create a workflow, and that workflows that does certain things. So in what way does it differ from, let's say, let's keep it in Java, you have a method and it calls like a bunch of methods where you have some ints and some outs. What's the difference? Why should I use LangGraph4j for that? I have my programming language and this is just fine.
Good question. Very good question. And we are not prepared to do this question. No. Behind the scene, okay, yeah. And at high level, I think that is what you are seeing. You can see methods that are called. And depending on input and output, you can change something with if, switch, and constructor.
Right.
What LangGraph do better? What LangGraph do more? Okay, it's a matter of every workflow, every framework or workflow do something. This is very important. Manage any context. So LangGraph, you have seen in your metaphor of call method, each step on LangGraph is like a method. You have input and output.
Right.
What is different? Because behind the scene, the input is translated is a concept, the concept of the context. The context is created as immutable object that when arriving input, you can't change. You can just read.
Right.
And you can perform something. You can contribute to this output. Means that you can contribute to this context. You can add something to this context. Also, you can ask to the graph to remove something. Ask to the graph. You can remove. So in the okay, you can ask, please remove, please. At the graph behind the scene, understand if there is a consistency in this request. Okay, and so the first thing that there are one instance of context that flow during every step that is immutable, and you can contribute to this context. So the context increase the meaning during flowing in the workflow. And behind the scene, LangGraph also store this state for each step. This is very important. So there is a concept behind the execution of the node that is checkpoint. So before call an action or method, as you say, the LangGraph save this, creating a checkpoint. So it say, okay, I have to call this function, I have to call this action. So this means that I am before this action, I create checkpoint. So in the checkpoint, I register what is the next node, what is the next action to call, what is the state that I have achieved until now, and store in another concept, that a side concept, that is checkpoint saver. You can create a checkpoint saver with different underlying technologies, like Postgres. You can store Postgres. You can store inside other DynamoDB. You can store what you want. So this means that you have a before call and after call, and before and after are saved. This means that if inside the action there is an error, you can intercept this, and inside the saver, you can evaluate that you have an exception, you have an error in that moment, and you can resume the graph and say, because probably there is an error inside the parameter of the context. You can, after error, you can, in post-analysis, in post-process, with another tool, if you want, I want to change this state and resubmit to retry. This obviously could be also in automatic way, no? And this allow also a very important feature, but it is simple. It's like managing error, that is suspend graph. Everyone, in particular inside the workflow in enterprise, you want that in particular step, in particular phase of my workflow, of the workflow that I manage, I want to involve the human. I want to involve the person that have to check.
Yeah.
So I will process my purchase order. The last use case that I've done for a customer, I process my purchase order, and after that I extract all financial information and also related data and code inside this huge purchase order. I want to say, I create a summary inside the context, and I want that the customer ask me, I want to approve. So how to achieve this? It's very simple. I've introduced inside LangGraph the concept of interruption. You can say to the node, I want to interrupt before or after this node. This interruption means that the workflow ends and running. And you can evaluate inside the saver, checkpoint saver, say, okay, I want to continue, I approve. So you create a ad hoc attribute inside the context. Let's say continue or not. And you, in post-processing with another tool or within a tool that you provide to the customer, say, okay, yes, I won't proceed. Okay, or I won't proceed, but I won't change this information. And you can resume. So resume means restart the graph, put inside the graph the context that have saved with your change, and the graph restart from the same point with the information that you have provided. This is the human in the loop implementation. This is very important, and because you can involve human in some approval, we see this kind of the approach also inside our code development AI tool that ask us, you approve that I change this file? Yes, I want. Yes, this is a kind of approval inside the workflow, and you can achieve this. This is the management error and the human in the loop complete the processing inside an enterprise. Another feature that asked a lot of the contributor, a lot of the discussion behind the LangGraph was the parallel node. So idea that you can start, you arrive in the node and you can do like a fan out. So you can start a lot of tasks in parallel.
Oh, yeah. Mm-hmm.
Okay, I have implemented this because this could be a decomposition of complexity. I can, for example, I use this to process a purchase order page by page. I create an agent for each page, for example.
Yeah.
I have 11 page. I can create 11 node that elaborate each page. And I, with the concept of fan-in, I use a node that join everything. This is a good optimization when you can process a lot of the information. Just I want to say one thing. LangGraph, this decomposition that probably someone that heard me, they say, I use Cloud Code, I use Cloud other tool that do this automatically. Yes, but there isn't a problem. When we arrive in enterprise, someone, they say, I don't want that my data go out over internet inside the AI. I don't want to spend too much token. There are common questions. There are common questions that inside the enterprise say. And if you your approach is not loop engineering, is not just to put inside an agent that is autonomous agent. If you think about the workflow, you can also decompose the complexity. You can create a node that do use an agent inside the node, but that do just one thing, one task, or more controlled task. And after the result, you can check the result in another node that must not be an agent. You can your code say, okay, but the result is what I expect. I can put it. So this is very important also to create, also to require for a complex processing less AI power. Local model,
because you have the full control over what is done actually.
This helped me to respond to my customer. Say, I don't want that my purchase order flow inside the internet, inside Anthropic or OpenAI. Also, if I have a guarantee, I don't want.
Well, if you're using LangGraph4j, you can freely choose any LLM model, really, because you can use Spring AI or you can use LangChain4j, which both provide almost any possible connection to any possible model provider, basically, right? The one thing I do not fully grasp yet, because you said LangGraph was as a side project from LangChain, even in the Python world. I don't fully understand what this has to do with LLMs, with large language models, because that's, I mean, they work nicely together as you explain it. But I don't fully understand. I could use that workflow without any AI. It would make sense, I'm pretty sure, in some cases, to have that a workflow.
Generally speaking, is perfectly as you say, but this association has been created originally by LangGraph in LangChain Python, because every agent that company has delivered was built with LangGraph.
Yeah.
So, and also
Okay.
in my, if you take a look my code base, I have created AI agent using LangGraph and not using LangChain4j implementation or Spring AI default implementation.
Yeah.
This is important didactic code, because you see that, for example, when a person, when developer use an agent in LangChain4j AI service, is wonderful abstraction, or Spring AI chat service, it's another wonderful abstraction. You don't see too much when the tool is called. Why? You put advisor, you put your tool, and everything happen behind the scene. But if you take a look to implementation of an agent in LangGraph4j, you see that there is a step that reason, and output is just information that are useful to call a tool, but the tool is called in a technical step. So you have immediately evidence that the harness, that because LLM is not able to call a tool, LLM is just reason
Okay.
and
Yeah.
create information, and the harness, so the infrastructure called the tool, not
Yeah. Okay.
not LLM itself. And
Right.
this is is why has been related, because it's been closed to the LLM, the LangGraph. But you can use, you're right, you can use LangGraph also as a workflow, a simple workflow.
Yeah.
In my
Okay.
typical approach, I use inside the step the agent, or from Spring AI, or from LangChain4j. So I use AI service, for example, inside the the node, and or Spring AI chat service. And there are the suspension, the human in the loop, and also this thing are more related to AI problem. So the workflow is this LangGraph4j and this kind of the project, because there is not only LangGraph4j Spring. There is another implementation of Spring LangGraph, LangChain4j. I've introduced another implementation of agentic workflow, is tied to LLM, because have a lot of utility and facility
Yeah.
to integrate.
So
So
the,
during evolution, the LangGraph and this tool are moving so close to LLM.
yeah. Okay. So but I understand that it not necessarily has anything to do with an LLM, but it's just in the area of work that's used with AI. This is a perfectly useful tool.
Yeah,
That's what I
perfect,
understand.
perfect.
Yeah. All right.
So this
Okay.
is, and also the feature of the workflow are tailored in the classical use case that coming up using AI. Just
Yeah.
that. Okay. So it's a framework focused on the use case, UI use case. But if you want, you can use as a classical workflow.
Okay, so I would like to share my screen really quickly just to ask more questions, because we'll get to that to the full demo later on. I'm pretty sure, but what you created here is a really simple workflow.
Okay.
So okay, maybe just to start this off, this is an application that I wrote with AI. That's basically the purpose is to find a connection, any kind of train connection, monitor that, and if there is a delay, then an LLM will start up and find a useful alternative and suggest that to the user, and the user can then select one, and then I think it's booked, at least in theory. And the workflow for LangGraph4j is here really easy. So it analyzes the delay. What is it called? It's a step, right?
Step, yeah.
Yeah. So one step analyzes the delay and reacts.
I call LangGraph called node action.
Okay, so that's a node action.
Yeah.
And then the next node, if there is a delay, advisor springs into place, and that's probably LangGraph4j or Spring AI, right?
Yeah.
That's kind of a AI tool. And then there is an interruption because we are waiting for the human to decide. So the human can select a next plan of action. So if he wants to use another train or just wait for the delay or anything like that. And then after the interruption, if the human has made a decision, the decision is applied, and then this is done. Right?
Yeah.
Okay, and this is a perfectly simple workflow. But each of these steps has a defined in and a defined out variable. The in variable, or the in data, let's call it data, that's
context. We call state.
Okay, so that's the state. Okay,
state. The state.
What comes in is state, and that's immutable.
Immutable, absolutely.
And at the point where it starts this node, it could be saved somewhere in a database, for example.
Yes.
All right.
Depend. The graph have two main phases. One, you define and compile. When you compile, this means that LangGraph control the correctness. There are not dead end. There are not double reference. So there is a compilation, and you got a compiled graph. Compiled graph is a valid graph. After compiled graph, you can run this.
Okay. Yeah, well, we'll see that in the code later, I think, okay. Right? That will be something. Okay, and then I think, Bartolomeo, you created this bit of a bigger sequence diagram.
For a simple graph, a bigger sequence diagram.
Could you walk us through that just a little bit?
So, just, okay.
Can you see it? Can you read everything?
I have enlarged the video, and
okay.
Now I see. So involved, typically we have a web application where we start everything. There are some steps. So we have created a classical application with the service, nothing more than this. And so we have the first step, that the user search a journey. There is a journey result.
Oh yeah.
And now we have to we have also all of these things appear in our UI. We understand what are delay and so on. And after we decide, to perform some choose inside on top of the UI, we start to. We have also created all the information to provide to our agentic workflow, because LangGraph creates an agentic workflow. You start our agentic workflow. So we floating from click simulate delay, trigger delay. So we simulate delay with click.
Yeah, exactly. Delay. Because we can't be sure that we have
before
a delay.
we are on the UI, and we have to call classical service. Okay. After you click simulate delay, trigger the delay, create the first data information, so the first state, so the initial state, and start the LangGraph, the compiled LangGraph that we have prepared before. And we start with run the analyze delay, as before I've seen inside the simple workflow. After we have that advisor started to understand, inside this we have the agent that work, right? And we have in this workflow, we have applied what we say declared in the interruption. So we know that in that step we want to stop. So in this moment, because there are also runtime interruption that we can do. So we don't know that in this step there will be an interruption, and we have also applied interruption dynamically. But in this way, we have declared interruption. This is important in design phase, because you can say, okay, this step, I want that when the human is involved, every node arrive in the step when I want that the graph will be interrupted. In this moment, in this code that we will see after, we have declared interruption, and we after advisor. So advisor have an input information coming out from analyze delay, elaborate this information using AI, create another unit of information that contribute to enlarge the state, so complete the state with meaningful information. This information, remember, that are stored inside the checkpoint and are always available after, also for to analyze after, and arrive in the node that is declared interrupted. And this node terminate the LangGraph workflow and return. So because obviously that LangGraph has been run by our service inside Spring Boot after we see, and return to the UI, asking to the user, and this is a classical human in the loop. So I stop my agent workflow and implement around this stopping something that I have to put to the user to say, okay, what's your choice? This is my reasoning. This is output of my reasoning. What's your choice on that? I pick up my decision and return to the workflow. In this case, we have a very simple workflow. My image a workflow of 100 of action. So after I have to do a lot of other things. So I have to buy ticket, I have to booking train, I have to a lot of other things. So this is just representative. It's what could be, no? So when the user pick up a decision, so human in the loop. So we have give to user a final decision. We return in the service, pick up the same instance of our graph and say resume. This is another method. Say resume, and we in this moment we say a very interesting thing. We can submit, we can update the state outside from the graph. So this means that we can change something, because if in the state there are seven choice, and the user choose the fourth one, we update the state and say add a probably new attribute in the state outside the graph running, and say the user has chosen the fourth one, and create a new state, put inside call resume, put this new state inside the resume, and the graph, the workflow start from the last node that's be executed with the new state. That is what is saved before, more probably one or more choose of the user. You can also involve more user, for example. No? In my experience, I have there are multi-approval steps. So I have several users that have accepted, and update the state and put this information inside the graph. The graph run again, starting from after the human decision and apply decision. That is step after. Apply decision is an action that have all the information that has stored before, more the decision of the user, and this is up to you to implement the action that applied this decision. And after the workflow end, this could be repeated obviously as many times you want. Okay.
This is great. I was just wondering. So you said the advisor, it will be a call to an LLM, and is that something that people do to have, for example, a call to an LLM, and then in the next node action, we have another LLM that just tests the output, like applies some guardrails or apply some fail-safe that it's making sure that it's working, or use some other LLM to actually check the output of the first LLM.
This is what always I do and I suggest to do. So in this case, obviously this is simple, but in this case, advisor just perform. There is an agent, a small agent that it's implemented with Llama. It's very small, that just is able to understand, the skill of this agent is able to understand between different delay and so on. And after that, the guardrail in my approach is a technical step that arrive after an AI agent, because evaluate the result. So, and as you say, it's very important. You can put a technical step, and you can also decide that after this technical step, you can review, you can involve another agent to review the information. But just because after technical step, I can sanitize the information and put more focused information in agent. Remember before what I said before, we can architect a workflow to keep simple AI involvement. A lot of small agent that not necessarily hundreds of billion parameters, but are focused on particular steps, particular task. This is very important to have in the mind when you use similar approach. Okay. I have answered your question.
Yes, absolutely. So I think I got the basic idea. So for example, if I apply those guardrails, you wouldn't do that in this one node action that calls the LLM for the new for some different tracks, for some different connections. You wouldn't put that in the same node action, but you would call another node action after that to apply those guardrails, just probably for traceability reasons as well, right? Or for failsafe. If something breaks, if the system stops for some reason, you have your whole workflow stored in some kind of database, and you can resume from any point at any time again.
Absolutely right. Your observation are in the right way. So when you speak about traceability, you speak about enterprise feature.
Oh yeah.
What every enterprise customer want.
Yeah.
So I don't want to join the action. I want to separate the action, because behind the scene, as I said, LangGraph trace, save, and guarantee. So if you split in more action, you have more control after. You have more traceability, monitoring. It's better. And also, I think that also the approach in the mind, decomposite something, make more simple to share to another developer, to customer, what the workflow do.
Yeah.
Okay. So
Yeah,
also
absolutely. For debugging,
important.
for example, as well, right?
Yes. Also,
Yeah.
this is very important. Share information is not just a matter that works, but works in the right way, and everyone understand what I do, you do.
Yeah.
It's not we have not underestimated this. This is very important. Okay.
Ah, that's cool. So I have to continuously
Too much,
ask
too
because
much.
I'm so interesting. I'm so interested. So the advisor, for example, the output of the LLM, we can read that text plainly in the decision tree or in the workflow history, I guess. Is right?
No,
No.
not always.
Okay.
Typically, and here coming to the play LangGraph4j, Spring AI, because they have incredible feature of structured output. So,
Yeah. Mhm.
so I always use that feature because are very amazing. So this means that when I involve a LangChain or Spring AI agent inside the visor, okay, I use structured output feature, and that translate text in something that I can technical use, because technical task is will be complex manage text in technical task, but
Mhm.
is easier manage structured data, okay, class or record or some kind of this stuff. So every agent, when you create inside an action of a LangGraph an agent with LangGraph or Spring AI or whatever, I use these two, use a structured output feature in order that you can have inside the state something that technically is easily to manage, right?
Yeah. But if you want to store that in a database, you have to kind of serialize it at some point, right?
Yeah.
Yeah, that's done through serializing. Well, I guess you can select the provider or something like that.
Yes, absolutely.
Yeah.
If you is just there is the database, the saver, the checkpoint saver behind the scene are for example Postgres. There are several tables, and the state is serialized in one table. There are a lot of information, relation, and also the diagnostic information, also that say the step, but the real the object are saved, serialized inside the database.
Yeah.
Okay.
Okay.
And if you can avoid to save your data in other data source, because LangGraph guarantee for you that all is saved.
Okay. And I think I just packed two questions before, because I was also asking about history. Is there, yeah, there must be some kind of history of when which action node with specific parameters was called, right? That's the traceability.
Okay. If you want to focus a bit around the checkpoint saver strategy,
Yeah.
there is the most important thing that every run of the LangGraph is related to a thread. Thread is like a session ID. You provide a session ID. Every information that are stored inside the checkpoint saver are related to this checkpoint, to this thread ID.
Yeah.
And if you reuse this thread ID for more time, there is an auto versioning of the
All right.
thread ID version 1, version 2, version 3. And when complete, this is very important, because in the new release that I am final at the 1st of September, I release the new version, and that increase this information around the checkpoint saver, because are the most important feature in enterprise workflow. And when you complete a workflow, you can interrupt the workflow when it's completed. And when it's completed, the thread ID and all information are stored like a tag in Git.
Okay.
For just for given understanding.
Yeah.
So there is a thread version, and all information are stored as a Git tag. It's not a Git tag, but as a Git tag. Okay.
Yeah.
And there are other two possible interruption, or when the termination is the good termination tag, but the tag is also created when there is an error. So there is a tag, and this tag is, there are information in the tag, there's error and where the error, and you can also contribute. So the exception that is raised is stored, and also some message say, in this moment, this thread in this time has filed with this exception, or all this information. So there is a tag also for error.
Okay.
And there is another interruption. We use we are aware of this interruption. So human in the loop interruption. This is another interruption. So because imagine that we can interrupt indefinitely a graph, no? We can expect for day, for week. So, okay, it's not a matter of a second. We can also say a long running. We say the good guy say, the good architect say, the long running graph, no, the long running workflow. Okay, so also interruption is stored not like a tag, but as an open tag. So you can create, I'm creating, for example, for a customer, a tool that he can open a dashboard and say, oh, there is these are all the execution that was in error. Oh, we have all completed, and there are 3 interrupted. And you can click on the user interface, say, I want to resume this. I want to understand why it's interrupted. Okay. Or I want to try to recover this error. Click and say, replay. Okay.
Oh, okay.
Also this is obviously nice. I have created a small tool, but the infrastructure behind LangGraph make this easy.
Yeah.
Okay.
Very nice. Okay.
Oh, thank you.
Yeah, this all sounds really, really useful. So if you don't mind, I think we could go to the live coding anyway. Or is there something you want to say before we move on, want to explain?
I want just I have said a lot of things, but I want just say to the audience that LangGraph must not be compared with this incredible agent that we use for generate code. So LangGraph is useful when you have first, when you have in a process and you want to move this, refactor this process and introduce AI in this, or we want to have a complete control of what you have to do. And the last one, probably I already said, when you want to involve more LLM, and in particular LLM less powerful. So less token, control this. This is not, you have not underestimate this, because could be a problem. Like a cloud, I remember that when arrived the cloud era, architect started to use every service inside the cloud, and the customer say a lot, too much cost, and arrived the cost analysis engineering, and architect have to deal with the cost analysis. And the same could be in the future for the AI. So it's true that probably an agent solved this, but how much token? How much cost?
Yeah.
How much you have to repeat this? It's a deterministic. You can replay this, and the token are always the same. The tasks are always the same. It's very complex now, probably in the future, but it's very complex now to understand. LangGraph, like the tool similar, help you to do this.
Yeah.
Just okay.
That's what I understand as well, that you have more control over the LLM and what it does because you have to cut it in small pieces. And by doing that, you can control it more easily and control the whole context of the LLM as well. So if you only give it exactly what you want in a small text format, that doesn't use as much token as, I don't know, a AI harness that has your complete code base in the context and actually just you just want to rename something as a method or something like that.
Are always in my experience say that there isn't a best solution or a silver bullet. No, depends.
Mm-hmm.
There is a good solution, depends on the context, like we say in the pattern. So I think that that agent works well for generated code, work well for that context. But again, if you move in enterprise, the customer asks control, predictability, cost, and a lot of the this feature imply that you have you open mind and have understand that there are also tools like LangGraph that allow you to see the AI approach in another way, not just a loop that do everything.
Yeah.
Okay.
Yeah. Just really small function calls.
Perfect. Really,
that you can
as
use.
you said in your metaphor. So you can control your code. You call function if in some way is like that, but there are a lot of features, enterprise feature behind the scene that help you to do this in a controlled way, monitoring, predictability, and so on.
Yeah. Okay. Great.
So it's up to you, the code.
yeah. So let's try to explain the groundwork that we did. So I built something with Bartolomeo, but as I built this application, I kind of figured out that this wasn't the ideal scenario for AI in general. But that's what we built, and let's just try to understand how to implement LangGraph4j in this. So as I told you before, the idea is that it actually helps you make a good train connection. Let's just start Docker Compose up. So this is the repository, and I have a Docker Compose. In it, there is a Ollama instance and a Ollama pool instance that actually just pulls one LLM. Yeah, this one, Llama 3.2. Yeah, here it is. And then we have our application that is a Spring AI, a Spring application, and that is built in this Docker file in 2 steps. And here we have our POM, and yeah, it's also using Vardin, Spring AI, and I'm not sure if it's using LangGraph4j yet. Yeah, okay. The dependency is already in there, but I am not using it yet. I will quickly show you how the UI works because that explains a lot about the actual application. So we have one question. We can answer that while it's booting up. So one LinkedIn user asks, with LangGraph4j, I can also orchestrate a fleet of agents. There are also protocols like A2A. For which cases would you advise to use LangGraph4j? Okay, that's a broad question.
Okay, I can say that historically the agentic workflow in LangGraph4j is arrived after that I started the LangGraph4j. So I have seen the implementation. I have also, and the only I have not evaluated in deep the implementation, and there is also the in LangGraph implementation to call A2A because there is an action for that. The only thing that I've seen that there are the specific pattern for in LangChain4j, and seems a common approach. So there are a pattern that split parallel path for the loop, and 3-4 pattern, and the LangGraph4j in this in this game is more open, that you can implement which pattern you prefer, and not just a set of a pattern that the LangChain in particular give you. But at a high level, I've seen that the problem again, it's very complex. And in using LangChain4j, it's very complex to split from the agent a technical task. The only way to do this is to create action, they create tool, they create MCP, but always inside the agent. There is it's in my knowledge of LangChain4j agentic workflow, I haven't seen a clear splitting between technical task and AI task. So as the user say, the fleet of agent, we speak always of agent, not speak about technical task, not speak about what you say. I can see a workflow that is not only populated by agent, but a workflow that agent are the actor, but not main actor, not necessarily main actor. This is my answer in this moment. It's obviously that LangChain and Spring AI, and there are also another. I don't remember the name now. There are also another grid tool from the Spring Embabel or Embabel.
Embabel, yeah.
Embabel, sorry for my pronunciation.
Okay.
That is coming up in the. But this give me and give us idea that. To move this framework in enterprise, we need to control the workflow. We need to have a big picture of what we are doing. And in LangGraph, this is possible.
Yeah. All right. So I'm also not completely sure as to how much control these agents in LangChain4j give you, if they are as specific and as constraining as LangGraph4j. That could be a difference. Okay, so this is the running app right now. And again, it does not contain any LangGraph4j yet. But the idea is that I can select a train station. I think it should work for Europe, but I tried it only for German for now because I had enough problems as it is. I can search for connections. I have a couple of those here. And for example, I can use this one and say, okay, I want to monitor this connection. And right now, all these trains are on time, which is actually good, but not good for us. So we have that simulate a delay button to actually delay it by, I think, an hour. And what this should do now is, it actually says, okay, delay detected, 65 minutes here. And it actually calls the LLM and asks it to find a good alternative route, which doesn't work that well. But that's not the point. The point is that it's actually, that is a workflow now, and we can select a different train, and then this is the result. That's all there is to it. And if it is a smart move to have an AI select an alternative route, that's a completely different question here. And I think that's where I failed with my example. But the point is, let's look at the implementation really quickly, because we have that workflow orchestrating service here. And what that actually does is it has a workflow executor, which is just the executor service of Java. And this is really, really easy to understand and really easy to implement. But if there is any problem at any point in that code, it will fail and you can't reproduce it again. And that's what we actually want to change. Yes, exactly. So what I would like to try now is actually tell the AI to adjust that project to use LangGraph4j. Yeah. So I have GitHub Copilot ready here on my repository on local. And I will just tell it to implement LangGraph4j in the workflow orchestrator. Not sure if this is enough for it to understand, but it could be.
Without a skill, this is like a miracle.
But well, is there a LangGraph4j skill?
I'm working on that.
Ah, perfect.
Yes.
Very nice. Yeah, this
I want
is my
during this generation. I want also try to give a bit to the previous answer, because I don't want to give an image that I want to compete or say that LangGraph is better of LangChain or other like stuff like that. I just want add to the guys that asked me that obviously another advantage of the LangGraph4j that is not opinionated. So if you are not have not choose the hat of LangChain4j or the hat of Spring AI, LangGraph is a good solution. So you can implement things not so also comparing the two other framework, no? So probably if you are experimenting using LangGraph, could you the free to use LangChain4j or Spring AI, depending on what you prefer. Just that.
Yeah.
Because
Spring AI is only exclusive for Spring. I think you can't even use it in another project. I'm actually not that sure. But LangGraph4j, LangChain4j, you can use in any system that you want, even in Spring. But LangGraph4j is even independent of that implementation. So you
independent
can
of
use
the
Spring
implementation
AI.
of the framework that use LLM.
Yeah.
So this is a independence. I'm also moving. I'm also in a laboratory of my friend in US. I've also tried to move in GraalVM and Java Virtual Machine GraalVM, and also use the Python LLM like from Hugging Face, using LangGraph and Python implementation of LLM.
All right.
So, agnostic, well, just for experimentation, just for fun.
Okay. So it's researching a lot of LangGraph4j's API. So yeah, I guess a skill would be useful here.
Yeah, very useful. I've tried. I use AI. Actually, currently, LangGraph is built at the 95% by hand, not by AI. But I use AI for all the CI/CD and for documentation in particular. For documentation, because it's very complex to have a quality documentation in open source project when growing so fast, and so AI helped me too much for that, because the community is very require at the first a good documentation, after the good code, the first good documentation, otherwise you are nothing. And probably this GitHub Copilot try to reading my documentation.
Yeah, it's taking quite a long time. I'm not sure if that's good, but
I won't say, John, I won't say another thing. During my porting of the LangGraph at the beginning, I say that there was a porting of the LangGraph Python to the Java. I've also tried to experiment not a book, because in Python not a book are incredible, no? Incredible feature, and also Streamlit, that is incredible. I don't know if you know Streamlit and Notebook, Python Notebook are incredible tool that unbelievable tool. And I will also, I hope that in our audience there are someone that know this. And I have also tried to move in Java. I find out something equivalent of Streamlit and Notebook Python also behind the LangGraph4j. So if someone is interested to understand how use Notebook in Java or Streamlit approach in Java, in my repository, I have also written some article in my blog, but there is this interesting exploration.
Just to show you, so you have currently 1.9k stars, and that is pretty huge.
Yeah, John, not so much, but for me it's huge.
But the thing is that, and I told you that before, for me it was really strange that I never heard of LangGraph before our session. Well, a couple of weeks before our session.
Unfortunately for me,
yeah.
Again, it's a complex, because there are this discussion helped me to try to explain. I hope that it's enough clear, because there are a lot of tools, in particular in the Java ecosystem, that gain more attention. There are a lot of speakers, there are a lot of the video behind, and obviously the people are attracted because they work and they want. But I try to do the best. The only thing I can say to the audience, and that I use it in production. So it's not just for an experiment. I use this, and a lot of the feature are because I need that feature. And again,
Yeah.
there are a lot of contributors that have created Oracle Saver, Redis Saver, that because and there is also DynamoDB Saver. I think that there is also a Lisa project in this page in the README that use this, and there are also a porting on Android. I've seen there
Okay.
are so there are a lot of guys that experiment around, and I'm glad that there is interest around this. And again, probably I don't know, because I monitor also the competitor, and there are a lot of the great work, and I use LangGraph4j, Spring AI. I always update the version, because I want that LangGraph4j is use the last version, the last feature from this tool, because it's very important. And probably in Spring AI have implemented, not directly have implemented agentic workflow, but there are side projects, Spring community util that use that. And I have tried to understand the strength and the weakness.
Yes, you try to understand them, and what
No,
what's
because when I explain the LangGraph, I have also the question that before, why I will use LangGraph and not LangGraph4j?
yeah,
Why?
yeah,
So a classical question. And
absolutely.
probably if we will have an opportunity to show a complex workflow that I build for some customer, probably make more sense. What does I call control? I've also implemented the telemetry with open telemetry, because
Oh, yeah, I just saw that. Yeah,
yes,
here.
yes, because one of the feature that community asked me was the do you remember that I have a checkpoint before and after?
Yeah.
And the community asked me to expose something that also the user of the LangGraph could be intercept this. So I have implemented the concept of a hook. So you can put hook before every action, after every action, hook for entire workflow. And OpenTelemetry is just an implementation of this hook. So you
Yeah.
can eat your own food, say so I create hook and create
Yeah.
development using hook. So
Yeah, yeah, yeah.
using hook. So this is important. So there is also this, and the Spring AI call advisor, this kind of approach, and also LangGraph have this. And another curiosity behind, sorry, John, when you are ready, you can stop me. Another
Yeah.
curiosity that I have started this project, and in Java at that moment there was not a synchronous iterator that there is in Python and in JavaScript. There are this very cool feature, asynchronous iterator. And before started the LangGraph4j, I have created a side project, Java synchronous iterator. So this is just one dependency of the LangGraph4j that is async iterator. This async iterator make the LangGraph give to LangGraph idea to use an iterator, but it's completely asynchronous. So this is could be interesting feature. I'm moving this also in the version 2.0. I'll move this asynchronous generator to support also the very asynchronous the Java flow, so reactive programming and so on, and also the Reactor project.
Yeah. Okay. I think I'm not deep into deep enough into all the synchronous iteration. But do you think this is something that could be done with the new Java version now, or is that something very different and it's very, very specific?
No, this is in real. I follow. Obviously, I follow every release of Java, and I want to move as soon as possible to until to Java 21. But asynchronous iterator in real, there isn't the only asynchronous iterator that I've seen is the reactive stream. Stream. This is I have created an async. There is not in Java until the 26. So there is a like a iterator that manage asynchronous task. So you can use this iterator like a stream, classical stream, a classical iterator, or a completable feature object. Okay, so this is because I would like to give the developer the possibility also to use a synchronous iterator for in or stream, but also if it is completely in asynchronous fashion, you can use the call chain that the completable feature give us. Because I have used a completable feature because it's the feature that is close to promise in JavaScript. For this reason, I've used moving from Python, from JavaScript. So I have tried to find out the more close concept that match with the Java, with the previous language.
Okay. All right. So it did implement what we asked for. If it is really what we asked for,
I'm really curious to understand the output, to see the output, to understand.
Yeah. So let's just quickly see what was done. There was some nodes created.
Perfect.
The delay workflow state was edited. So it's an agent state. That's new.
Okay, the great, yes.
Okay.
Very cool.
And this is all
really the agent, the state is like a map, or is a map. But the concept of the state, you can wrap the map with your custom attribute in order to make easier to work. And the AI have done exactly this.
Is the state something that you have one state object for one workflow?
Yes. One instance. The state
one instance.
Conceptually, the state is the same for the single class of workflow, but for each running there is an instance of the state.
Okay. And you said before the state is immutable, but only within one node action, not within the whole workflow.
No, is it the state? I guarantee that the state, when entering each action or exit outside the workflow, became immutable. So I create a copy. I gain a copy inside the workflow, but I share a copy to outside or inside a deep copy inside the node. So that this is guarantee that you can create side effect on the state.
Okay, understood. Okay, we have a delay workflow config, and that is.
Now they use the memory saver. This is the simpler, the first one.
Yeah,
memory saver. So it is just the saver that save everything in memory. This is just for POC, just for example. Okay.
Yeah. Well, I did not know about this. Otherwise, I would have probably also set up a Postgre database, and then we could have seen that. But all right.
But it's good because you start to understand the first implementation, you start to understand if all node works well. Try to, the saver is an feature that you can put on top after. It's not a saver that you inherit, no?
Right.
Don't affect your running.
Yeah. It's just one component that you can switch out easily. But this one seems important. So
yes, this is practically the essence of the graph. This is summarize everything. So the graph, you have a definition of the graph. So we call StateGraph. You can highlight this. Perfect.
Yeah, this one.
Okay. The StateGraph is where you put the definition, where you define the graph. The graph, every graph is defined as a node and age. Okay, so you can create the graph putting node and age. Okay, so age is the transition from a node to another node, and node is the real action. So you assign a name to the node and add action to the node. Okay. So
okay. So the analyze delay is a node.
When you can read this. Read the first statement. Var graph, new state graph, delete work state schema, delete work state new. This means that the state could have a schema, because you can you have a state factory. This means I don't create the state outside. I require a state factory, because the state is created inside the state graph, the graph.
Okay. Give me 1 second. So this is the configuration, and we have the schema. What's that? Oh yeah. Okay. So these are the different attributes or different values.
So
that are inside
different attributes, but the behavior inside the state could be different. So, for example, you could create, since you can't update the state, you have the concept of the schema. Remember, is immutable. You can't update the schema inside the node action. So, if you want to append something to an attribute, you have to create a schema that say, when you want append, when you return something, rewind, remember that state in input and a partial state in output. Remember the action?
This one, the human decision, has partial output.
No, the action. If you human decision node, click on human decision node. Okay, human decision node, perfect. This is the action. Okay, apply the state coming in input, and you return a map. So you have the complete state in input, but return a partial state in output. When you return, when the graph exec apply, okay, pass the input and give the partial state, merge the partial state to the original state. This merge could be subject to the rule. The rules are written inside the schema. Okay. So if I want to append something in the log, so log means that for each step I want to append something. I can do this inside the action because I can't update the state, but I can create a schema and say, when the partial state contains log, append to the state.
That's a lot.
This is for guarantee mutability. Because
But
the simple way is I can add the attribute to the state, but it's
yeah,
not possible because it's because change the state could be uh, create a side effect on
yeah,
the entire workflow. So
I see.
this escamotage, this strategy, this pattern has been put in place to avoid this.
So I understand that correctly. What does that do? It returns a partial map of the state. So whatever is there has to be part of that state.
Perfect.
And by returning that map, it automatically gets appended as a value, not replaced.
Not
So
replace. Perfect.
yeah, that's why this is a channel and not
Channel,
some object.
yes. The channel is an object. I have created several built-in channel, appender, replacer, but you can create your appender to guide, to drive how to merge the partial state to the state.
Okay. Yeah. So this describes that it's
Perfect.
appended.
Appended. Yeah.
Okay. So now I'm interested how it will use those different attributes. Those
These
different keys.
attributes, obviously, the AI has written the constant, but is just a key inside the map. All right. So just a log have a schema of appender. By default, the schema is replace value. So if the partial state
Okay.
return alternative as a key and a value, the alternative value will be changed, replaced in the joined partial state with the state.
Yeah. Okay. So if we would erase this, then
You got the last logging.
yeah, this would replace the last logging, but we don't want this. Okay.
With the schema, at the end of the your graph, you have all list of all logging that have passed between the.
Yes.
This is very useful for when you use the agent, because in the loop you have you put the context increase, so the message are appended to your history. So you can put the history inside your state. But you can also create housekeeping of state. So technical step that say, okay, I don't want this, no? Or you can create a circular queue that I want just 100 message and I want spin off other. So you can do a lot of the strategy.
Okay. Now, once again about this human decision. Yeah. So this is just text.
Yeah.
But we could probably also put any kind of serializable object in there.
This must be serializable, and there is a concept of serializator that you can put custom serializator to. There are obviously, I have created a lot of built-in, but if you want to create a complex object, you have to add this object to a state serializer. That is a concept behind there is an state serializer that is ad hoc serializer for the state. And now there are two state serializer built in, one that use Java serialization. But since I have had some community feedback that the standard serialization doesn't work well for class loading, I have implemented with the help of some great guys, very, very competent guy, a serialization that not use class loader, class for name for create. So you have explicitly create the object, and obviously there is also JSON serialization.
Yeah. Okay.
I propose, I suggest use JSON serialization.
Yeah.
That is the best way.
Cool. Okay. So I think I understand this part. So we can move on through the graph.
Okay.
So
Again, there is a schema. There is a state factory. Why state factory? Because the schema is created inside the graph. It's not created outside. This is very important. So there are two important concepts: the schema and the factory. After is this is very simple. You have a add node, name, action, name, action, name, action, name, action.
Yeah.
And after the age, design the relationship. Okay. So after you declare node, there are when starting age, there are the relationship. Okay. Add start. This is a particular node, building node. So start, after start, the workflow move to analyze delay. So start to try to execute analyze delay. After analyze delay, we go in advisor. After advisor, we go in human decision. After human decision, we go in apply decision. After apply decision, we go in end. Obviously, this is very, very simple, but too much simple. I imagine that audience are smiling on that. But there are, for example, also conditional age. Conditional age are the age that thank you. Conditional age. Conditional age is a particular age that use an action to understand how to move from a node to another. So you can create an action that could evaluate if I will move in from another node or I will move to. So conditional, it's like an if. Imagine what enter the state from outside an action. Inside this if, there is another action that is objective, is to is return, is the node that you have to move on. So it's dynamically. You can decide how to move depending on state.
Yeah, depending on the map that I give it.
Perfect.
And that's the state.
The state.
Yeah, all right.
You can there are if you before you have a state graph, try to try to after just to give to see all the method, because there are a lot of method on state graph.
Okay, yeah.
IntelliSense. Okay. Yeah. This conditional age is important, very important. And there are also the hook.
The hooks you talked about before.
Hooks for age, hooks for node, before, after, and also around. So you can inject also something that could change behavior, right? If you want. Very important. There are, if you see add the node, there is an add the node, the fourth add the node. Okay, no, the below. No, okay, no. up. No, there is a parameter. Another down. If up. Okay, if you see, there is add the node with the compile graph as parameter. This means that you can also add the subgraph that are a very, very important feature. So we not only could create just action, but you could create several workflow and put this inside another workflow. So enforcing the concept of subgraph. So imagine that you have built the graph that work well for a good task, but you want to put this graph inside another bigger graph to do other thing. You can consider a graph as a component, as action, and put this inside another graph. This allow us to create more complex graph, combining other graph.
Yeah. Okay. That seems like because you talked about like a couple of hundred nodes in your workflow.
Yeah.
I imagine that being very how do you say that? Not very good overviewable. I missed the word, but very confusing. Simple as that.
So
yeah.
the first one of the first thing, the thing I have had this problem, and I have created an feature in this graph that create a representation of the graph in Plan2ML and in Mermaid. So when I define a graph, also with subgraph and so on, to have an overview. So an overview that I can, as an architect, I can view, I can discuss about. I use this feature that extract from a graph that I define the code, the diagram, automatically diagram.
Yeah.
Using Plan2ML, that is a diagram as a code tool, or Mermaid. And I work on that in order to understand if everything, to have a big picture to discuss.
Yeah.
But
okay.
the confusion, the confusion, because there are a lot of nodes, but as you say, it's like a builder. You see every node. I think that the problem here is to find the right name for the right action. So it's important to give the right name, because the name also appear in diagram, and also appear inside the diagnostic, also appear inside the log, also appear inside telemetry. So this is a responsibility of developer. I haven't guardrail for this. I haven't utility. This is just a responsibility of who build the graph.
Yeah. Okay. What are the two most difficult things in programming, right? One is naming things, and I don't know what was the other one. Naming things. I forgot. But there are two really different difficult things, and one is naming things, naming variables, methods, and so forth. Yeah. Okay. But that gave me a very clear picture. So let's move on from that. We got our state graph, and now we need to compile it for some reason.
No, there is a reason. It's very strange. Weird. Yes, I have inherited this from the original LangGraph design, and I have had the same reaction of you. Why I have to compile the graph? Why? I've studied, and I think that is an incredible feature, because the graph, this is an oriented graph, and the compiling, it's in a way to verify if there aren't dead node, if the graph is coherent. So every path arrive to another node, so is consistent. Okay.
Yeah.
So there is a formal validation. There is another. Also, if you use a conditional graph, there is a verification if you have put in conditional all the node that exist. So there is a formal validation of the graph. Okay, and in compiling there is also some creation of some technical node that allow also the telemetry and so other stuff. So
Yeah.
the graph is added with the technical node that help for some tasks. Okay.
So, for example, if I would maybe erase this, then the apply decision node would never be reached. Is that something that would throw an error here?
Throw an error, yes.
Yeah.
Or you going to a non-existent node, there is an error. Let's say there is not this path, there is not this. So you are pretty sure that what you are designed works.
Yeah.
Works formally, but depend on action.
Yeah. Okay, but this is just some like compilation. You check the graph beforehand.
Yeah. In the compilation, there are some configuration that you have to put. There is a compile config. The compile config in this case, the AI have understand that there is an interruption and have put this is a declared interruption. So in compilation, I can say during compilation of graph, take in consideration that I want that the graph will be interrupted before call human decision node.
Yeah.
Okay, this is compiled inside the graph, and when every age try to arrive inside the human decision, whatever age, the graph will be interrupted.
Yeah.
Okay, this is like a interruption by design. So when decide the graph, you know that that node must be interrupted. Okay.
Okay. So one last stupid question: is there any kind of graphical tool where I can draw my squares and place some arrows to some graphs, to some squares, and then I have my workflow and I click one button and it creates this for me?
You speak about a tool that help to create this?
Yes, to create a workflow, just like Plant UML, but graphical.
Yes,
and
I have started to create a designer
using
graphical,
very good,
but
very good.
The community have not not give so much feedback on that.
Oh, really? Okay.
Because they asked me, it's real better that you provide us a skill and not a tool.
Okay.
And
interesting.
In some way, I agree with my community.
Okay.
All
right. It's just a thought that popped immediately into my head, because this little code looks way too complicated for something that is drawn in, I don't know, four squares and 4 arrows.
But I want to say another thing, because the project is have a lot of assets. Yeah. There is for this I have had the same difficulty, no? And for this I have created what I call Studio, LangGraph Studio. Yeah. LangGraph Studio is in documentation there are also some pictures that make clear, is a web application that you based on in what now is based on, if you want to use Spring Boot, Jetty, or also Quarkus, that you can put your graph inside this application. Okay, there is an interface you have to implement, very simple. Start the server, and the workflow appear graphically, and you can give him the input parameter. They start all the steps highlight when run, and on the right side you see the steps, the the state transition for each step.
Yeah.
So you can monitor, test in visual way. This is this studio is very useful for test the first phase of test and understand the behavior of this this graph. And I have in the last version, this is not yet released, it is beta 3. I have also created a viewer. So also this, unfortunately, is not ready, but also for your application, if you put this module, is like a starter of Spring Boot, you have a service that you open in a web application, and during running of your code, you see how the workflow, which step is under execution, interruption, and also the state in graphical way. This is because there is needed of that for complex graph.
Yeah, I think so. Okay, yeah, cool. So I just remembered, because the first time I went into software architecture and development, I thought, well, if we are structuring all these classes in UML diagrams, then there must be a way to automatically translate those diagrams to code and vice versa to put it back again as well. And there are tools for it, but they break so fast, or no, they don't even break, but they are just useless so fast. So I imagine I imagine the same for you, for your workflows. Sorry.
No, the same experience for me to translation is
right.
Became quickly useless.
And probably it's the same with the workflow. So if I draw a LangGraph4j workflow and I translate it one time, then this works one time, and then I'll either never use the implementation again or never use the graphical interface again. And then
I think we can't say useless, but it's not enough useful as we expect.
Yeah. Okay. Oh, cool. We just have a little feedback from Fernando. So amazing event, guys. So great to go step by step discussing and understanding like a pair programming demo. And that was basically the goal. Thank you. Yeah. But basically, I'm not sure. So we compiled the graph.
Yes.
What else is there to do?
Compiled the graph. So
exactly.
This compiled graph contains this transformation. Is like the code, no? There is source code, a byte code. This is a byte code. This is a representation of our graph definition, and this is ready for running.
And then this is actually used at some point, I guess.
Yes. We have to understand where.
Workflow orchestration service. Oh yeah. Okay.
Wow.
So let's go into that one.
I think that you use some skill or not. Are you sure?
Yeah.
You are lying.
No, that wasn't a skill at all.
Oh, yeah. I'm impressed of a generation of that. For LangGraph, I never imagined.
let's see what model it uses.
LangGraph is AI is aware of a LangGraph in this way.
I really can't tell you what model was used because I used auto mode. But yeah, I mean, AI is getting better and better.
Better, yes.
So maybe that's, or probably it's your documentation that improved, and that's
why it's I expected this for you. Thank you.
Okay. Yeah. Okay. So we have that graph here in our service.
Yes.
And It's still using the workflow executor service.
This is not correct.
Right?
Because AI have say, okay, we want to execute in asynchronous way. So the AI create a workflow execute, but graph it's internally is asynchronous. So
Yeah.
it's not not needed to create a workflow executor.
So if as soon as I send off these commands, the method is done anyways, right? Because that's asynchronous.
Just to explain, I've seen before that I've created a project asynchronous stream. As you say, when I run, forget workflow executor. When I run a graph stream in the 68 row, 68 graph stream.
Yeah.
Okay, graph stream input config stream for each. I have translated the synchronous stream in synchronous stream. Okay, so this is the classical Java stream. This means that this is a particular way that the graph running, and every step you have like a for that a stream that every step that is executed is put inside the stream. So you can monitor in this for every stream that are executed. Okay.
Yeah.
It's like that you is like that you say next, and the workflow executed your will.
Yeah.
But if you instead of a stream try to put dot instead of a dot stream.
Yeah. Parallel stream, right?
No.
Oh,
No.
okay.
No. Okay, you
Oh,
say, for
the
example,
graph maybe.
No, stream.
Yeah. Okay.
Instead, dot for each async. Dot. No, stream.
No. Here. Okay.
Yeah, perfect. For each async. Yeah. This is a stream that I have created. A stream that it's a class is similar to the stream of Java, but in async. This is executed in async.
Yeah.
Async, without without a need of workflow executor.
Okay.
You can.
So you would prefer this one,
Absolutely.
I guess. Yeah.
Because this already have a particular thread and run inside this thread. Okay.
Yeah, understood.
You can also, there is a default thread, but obviously you can also create your executor for the stream. So there are several methods on the stream, and for each async, complete, map, a lot of that are all asynchronous way to evaluate a graph. But this is for me is a preferred method.
What I'm not sure I understand is what actually does start the workflow, because this is just debugging, right?
Okay. Your question is how can understand how the workflow is stopped, or
where is it started?
When we graph stream dot is like a stream, is lazy. It's like a Java stream. When you arrive to the final operator, the stream starts. So when you call graph stream input config, nothing happened.
Yeah. Okay.
When you dot for each async, start.
Okay. All right. Okay. So this creates a stream, a No, it does create a workflow. It does simply not start it yet.
This create an async stream.
This call does
create an async stream.
Okay. And then this one starts it.
This consume async stream. So start consuming. So inside this log, you can see every step that is executed. And when the graph end or will be interrupted, you exit from this.
Yeah. Okay, so I mistook this. This is a graph node for every node.
Every node there is a stream that consume node and give you the result of the node output. So a report for each node executed. There is this. So you can see node output with the state. There is with this node output. Say you give you the node ID, the state. Okay, all the information that you can use for logging, or also for do something that you want during graph execution. You can send. Typically I can send also the event from another system from here. Say because the graph running, and you have in this for each in this. Consuming, you can do what you want. Typically you log or you do nothing. Okay, and all works.
All right, so this already is enough, but something is done here. Retrieve the checkpointed state and push it to the UI.
This is not necessary.
That is probably the reason or the goal to see what everything the results of the workflow.
Yes.
So if we go into publish, what does that do? Get UI callback, accept. Okay. Ooh.
Yes, this is in a way that you can send back the result of the. But there are. This is not the preferred way. There are a lot of other best solution here to do this, because one typically. There is a lot. It's common that you won't consume all the stream. You don't want to have one step by step. You want to consume all the stream and just get the result. All right?
Yeah.
Okay. To do this, we are in coding live session, so I can to do this for each async. For each async is in a way. The return of for each async is a completable feature, like a promise in JavaScript. Okay, so you can create a pipeline. But if you don't want to trace, do you want to trace every steps?
Yeah.
Yeah. Okay. So after for each async, type dot. Okay. Then apply. Then.
Sorry, then apply, yeah.
Then apply, okay, perfect. Click confirm. Then apply is an operator. Is an operator of the completable feature that is an object from JDK. Okay, this want a function inside. Oh, perfect. So this is This as you see, this is an object. So when you consume all the stream, at end of the stream, in case of error, in case of interruption, or in case of termination, will be called then apply. Then apply have a return object that, unfortunately, this object multi-shape object, because the result of the graph could be in different way. Okay, could be several things. I show you in a minute. So I have created an object that help you to understand the result, the final result of the. So
okay.
type graph result.
I'm sorry. What graph result?
Con la G uppercase is an graph result.
Yeah.
Dot from output. Okay, perfect. No, stop here. This could be, if you follow the suggestion, you can use this as a, there is a suggestion.
What do you mean with suggestion?
Replace lampada, yes. Perfect. Okay. Then apply, this is, and this translate the generic result in the graph result. Perfect. Okay. Open another, then apply. Perfect. We have a result. Okay. If you say result dot, you have all this method. So the result focused on the is method. That is cancelled. You can see, say the graph has been cancelled because obviously we miss this feature. You can also cancel graph running. So there is and you there is an interrupt that you can as because probably you can won't stop the graph.
Yeah.
So is the possibility to cancel the graph. So preemptive, no? And so you can say, you can understand if the graph has been cancelled, if the graph has been released with the tag. Remember checkpoint? So this means that is released. Released means that the graph has been completed successfully. It has been created a tag. A tag
okay.
and you can have a tag. Or is empty, no result. Or, this is very important, is interruption metadata. Interruption metadata says that the graph has been interrupted. And in this, there is an object that contains where has been interrupted, the state that has when has been interrupted, and also metadata. Metadata are most important inside the graph because during the running, you can consume and add metadata to the information. So imagine that you want to share a label to the, when you approve this, you can add the metadata to interrupt the metadata, so you can return information to the user. Okay. Yep. And there is also the app state data, or is a state data or a checking point save a tag. So this is an utility method that means that return the last state consumed by the graph. That is perfectly what the AI want with the graph state of config if present.
Right. That's what we want actually. If this is the case,
you want publish. You must say, I want publish.
Publish.
No, in the AI have said
that. Yeah. Okay, I understand.
So
we put this here and we say if this is that, then we publish.
Perfect.
Snapshot is probably
result
as state data. Yeah. Perfect.
No, as state data or checkpoint server tag. This is an utility method.
Okay. This one.
Because this return data also if there are not a saver checkpoint. In this case, publish this return the map and not return the delay state, but you can simply say new delay working state with this. If you want to stay compliant with the code.
It would be nice to compile.
Okay. Perfect.
Okay, cool.
Then apply, typically then apply want that you return something. The last step you return nothing, so or you can use then accept. But this is not my feature. This feature of completable feature. Future object. Okay, but it's good here.
Okay. Okay, wow.
Okay, this is a way that you can consume in a synchronous way every graph that you build and gather the result from that. Obviously, the result, in this case, we have just to check is state data, but in this moment, probably we have to check if interrupted.
At what point you want to say you want to check if there is something interrupted?
Depend. I think if this is the graph, when I see the graph, I have seen that the first run goes in interruption, and the second run goes in the end, right? Remember the graph?
Sorry.
No, you can see up. It's very more simpler. Okay.
This one?
The first start go in interruption, and the second go to the stop, right?
Yeah.
So you have two running of the graph. One.
Okay. So
you have a run and resume.
So this is actually called 2 times now?
It depends. It depends how AI. The graph must be called 2 times, because the first times they stop because there is an interruption. The second time you call resume, because you want resume from an interruption.
Right.
Right. I have to understand if this start workflow is called, as you say, the AI has created 2 methods. One start workflow and one resume with the decision.
Yeah.
So resume with the decision is the second call, and start workflow is the first call.
Yeah.
Right?
Yeah.
Okay. So the first call goes by design, goes to interruption. By design.
Yes, but that does not mean this is true.
No, this is interruption metadata.
Oh yeah, okay.
Quindi it's better that you move this code in the second run, and we write the code for interruption metadata in the first run.
Okay, well, so this is the first run, and we have another stream at the resume. Okay, I did not understand that we actually have to stream that again.
Okay, this is very important. This is simple.
Yeah.
It's just okay. When we spoke about the human in the loop interruption, human in the loop interruption means that the graph stop and its execution.
Yeah.
Just that. You call method end. When you want resume, you have to call the graph, the same graph with the method resume.
But the same graph, it has to be the same graph object
because the streaming is ended when interrupted.
Yeah.
Okay. So we have used the same instance of a graph and say, okay, streaming again, but we provide graph input resume that say to the graph, start using the state that you have stored.
Okay, that is one important thing. So the graph, where is it created here?
Graph is created, we have seen before, no? That there is a where we have seen compilation definition. We have
that's
config.
a bean,
Here,
so
here.
it's injected.
This is one instance.
Exactly, and that's probably working here in this example because we only have one user. But if we would have multiple users, then they would all share the same graph. No?
Yes. No, this is important because the graph is stateless itself. At the state that change.
Okay, but you just said that you have to call the same graph instance if we want to resume. Yeah. Yes.
No.
Okay, but you can do that multiple times.
Dependent from the user. It's dependent of the state.
Yeah. Okay.
Like a session in the servlet, no?
Right.
Okay. What is the session inside the LangGraph? Because I understand your doubt. Because if we use parallel with the session inside the servlet, the session is a thread that we provide to the graph. If we have multi-user, we have to provide a thread for each user, like a session ID. Because a session ID identify the state instance.
Yeah.
Because at the state instance, the graph instance is always the same. At the state instance that change the behavior.
Mm-hmm.
Okay, like a servlet and session.
So what the AI tried is, I think, with a journey ID, right? So for every user, we have a different journey ID.
Perfect. If you use a journey ID, like a thread ID for graph, you never have a problem. Because a thread ID, in this case, a journey ID, is point to the right state information.
Right.
So if you have 100 user, you have 100 thread and 100 instance of state.
Right.
But one instance of a graph.
Exactly.
That okay.
Got it. Yeah. Okay. So I'm looking at the time from time to time.
30 minutes out of the out of time. Huh? I don't want to. If you want to continue, no problem.
I would like to just quickly finish this continuation. The resume with decision, I think, would be interesting, and then we can.
Perfect. Okay.
We can start.
Just for understanding for everyone, we have said that we have just one instance of the graph, the state, and in this moment we have two execution of the graph, not two instance, two execution. One, the first execution where we arrive to interruption. Okay, so we start the graph. Perfect. We fill the state. We involve AI. We fill the state. And when we arrive to interruption, the graph end execution, not end the graph, end graph execution. When back to the user, when the user accepts something, we back to the service and start the same instance of a graph again. Saying to the instance, saying to the graph, resume the state. So the graph understand that must start from the last checkpoint saved. Everything work. Right. When we stream, so start means streaming a graph. When we stream a graph, we can got the result. Result means how the graph is ended. So the first start, the graph end by design, by an interruption. The second start, the graph end with a checkpoint saver tag. So they finish.
Okay. So what I would do is
we need to get the end state, because in this code you need to communicate to interface the last state. Otherwise, this is not important.
So what we actually want is this one in the other stream. And this was, so I added this for each async now, and now we apply those.
Okay.
And then
you can remove this.
So the set workflow active is false.
Set workflow false. Why?
Oh, that's something that's from the journey.
Okay. Follow. So put this inside the. Okay. Before this, perfect. Okay. Cool. And this means the second run should end in the right way, got the last state, and send to interface the last state. In the first execution, we have to got as a result an interruption metadata. Okay, so.
Right, but we don't need to do anything with it. That's why we don't write.
No, we have to. Here. No, because in this we haven't not communicate to the UI.
Yeah, we don't. Do we need to?
I don't remember. I remember that.
Oh no,
probably we have.
Yeah. No, we probably have to.
Yes, you have removed some. This is not required for graph. This is required for the interface. For this reason, okay, perfect. You have just to change this. Instead of result is state data checkpoint tag, is interruption metadata.
Yes.
Obviously, for a robust code, you have to check more condition, but we absolutely know that the first step. And in this way, we can say publish, publish, journey, and result is interruption metadata state.
Oh, yeah.
Is.
No, this is.
As, sorry.
As, yeah.
As. Interruption metadata dot state. Dot state. Because interruption metadata, in particular, the state of interruption metadata is probably the agent state, so you can avoid to remove the delay workflow state. This is a problem of every update. So you can. Okay, perfect.
Okay. Okay, this is kind of tricky. I think I can understand why AI might not get that on the first try.
No, repeat. I'm curious. What is the
result?
What is the doubt?
Oh, just because you have to know so many things. You have to know that the graph here ends with a certain state. I wouldn't have known that from what we talked about earlier. And then this is very specific to wrap this all up and get the right data.
Okay, the problem. Okay, this is I never do this. This is a particular because the application is built in this way. I never do this. Okay. But there is the feature that there are several conditions that the graph could end. If you want to know if you have you must be aware for some way. In this case, you want to send this is not this is important for application, and without this feature we have the problem. If a graph haven't this feature, you got a problem, great problem.
Yeah.
Okay, so
I
you have
understand
to pay.
why we do this. I just say that this is
Because no, why do this? Because if the graph could terminate in different way, you in your opinion, you can expect if the graph is cancelled, if the graph is interrupted, if the graph go in error, if the graph has been released because you have a checkpoint, if the graph doesn't have a checkpoint, so it's not released. How you can represent? How you can check this?
Yeah. You probably have to check all. You probably have to be able to check all these things, right? I get why it's built that way. I'm just saying it is a lot of stuff that you have to understand about the whole structure of it to get where you want to get this code that we just wrote, right?
Okay, yeah, I'm okay. I got your point of view absolutely. Typically, the first line is the running of the graph. The other line are the depending on your code. When you implement human in the loop, you have to involve UI, and when involve UI, you have to interrupt, send to UI something.
Yeah.
And something means if there is a cancellation, you have to send to the UI as being cancelled. If there is an error, you have to send an error. If you want, if the interruption is not declared but is happen because you have a dynamic interruption, how to send to the user why has been interrupted?
Exactly.
All this instance of information in some way must be aware to the user. So I understand that there is a lot of but this depends on complexity.
Yeah. Completely understand. Yeah.
I'm Joan, I am open to contribution to make it simpler.
Yeah. If I would know something right off the top of my head,
I'm joking.
Yeah, I'm sure this complexity lies in the nature of this, right? I mean, as soon as you're going async, like you said, with exception handling, this alone is something that you have to think a lot about and catch in a very specific way. Not only in LangGraph4j, but in general, even if you have these parallel streams in Java, you have to catch these exceptions in a very specific way. So yeah, I understand why it is that way. And for now, we just
in real this code never rise exception because the future in Java control exception, and you never rise exception. You got exception. You have another pipeline that say on exception do that.
Yeah.
Okay.
This probably never catches anyway.
Never catch. Right? No, this probably is real. It never catch.
Yeah.
And when you LangGraph for every exception got this exception, create another exception, and put all the information that real meaning also for probably replay the failed graph.
Yeah.
So you got a particular exception with a lot of information that could help you to recover.
Mm-hmm.
But again, this is in the nature of the complexity behind the graph.
Yeah.
But okay, I'm sorry that is not so clear. I have created a graph result from that, and to give all the possibility state of result.
Yeah. No, like
No,
I feel
no.
like I stepped on your toe a bit. I didn't want to criticize the implementation.
The critics is not I don't consider critic a bad word. It's a good. I'm trying to explain that the implementation until now is a matter of a lot of trade-off and the complexity, and
Yeah.
obviously we need to put in place a strategy to resolve this problem. But again, it's the same complexity that there is in a reactive stream, and because asynchronous is complex. I hope that in the new virtual thread, the structured concurrency that coming that is in the new version will be something should be easier to achieve. I hope.
All right. So I recompiled all of this. Let's try it one more time.
Good luck, LangGraph. I don't know.
So yeah, it takes a little time.
Too much
just because
time.
of Olama, because it has to read.
Or there are errors, no?
No, I think it has to load the model into itself. So it's pretty busy right now. So can wait a few seconds. Okay.
Oh,
yeah,
wow.
we got something.
We got something. Yeah, it's good.
Yeah. So yeah, Llama 3.2 is really bad at this right now. But we got alternatives, and let's see what happens if we take one. That seems right.
Accept suggestion is the state that we speak. So you have a updated state to say accept suggestion. I imagine in the state there is a accept suggestion attribute.
Probably. So somewhere in that journey, right?
State, something like state.
We have the
no service. I think that down, go down.
This one. Here we go. The state.
Yeah. Outcome, select alternative, human decision. Okay, human decision, and this if we monitor the log, there is human decision. There is the information.
Yeah.
Okay, perfect.
Okay. Whew, it worked. Okay. Yeah, great. That's cool that we made it work. And I mean, AI did. I would say it did a decent job. It didn't work perfectly, but a lot of things were right. Just the one. The two instances of the graph stream, actually.
This, I think that this is not. They have used the idea that you get the state. The previous code, the AI have chosen to got only the state, not the status.
Yeah.
This code, we got the state from the status. I won't say just one last thing. This code that we see now is the same for every complexity of graph. We don't change this. This is the same code that you have used for 100 node or one node. In this case, we have just 5 node that say, okay, too much code for 5 node, but this code is necessary for UI. So UI, during this async processing, imagine that async processing is complex, but try to optimize when we have more user. In this async, we got the status, a send pushback, probably WebSocket or other thing to the UI, the status during this async process. And imagine that we can got if interrupted, if is closed, if is released, or if is cancelled, and send all this state to the to the customer or to other system. Okay, because if the user cancel, probably you won't understand that the state is cancelled. But again, this is a matter of the complexity increase depending on the use case.
Yeah. Okay. So we got one more comment. I look forward to see those strengths of LangGraph4j in your demo. And I hope we did see a lot of strength and how you can use it in a pretty straightforward way, at least. Yeah, and so Bartolomeo, thank you very much for showing me all of this and how it works, the complete history of it, why it exists, and why there is still reason why it exists.
But history is fun to say. Because without history, we lose the soul of the thing, right?
Yeah. Yeah. Okay. We got no more questions, but if you have any later on, Bartolomeo is on LinkedIn and on. Are you on YouTube? Yeah, you have a YouTube channel. Yeah.
Yes.
So
LinkedIn, YouTube, Discord.
Discord as well. All right, and
Yes.
and X, Twitter.
X Twitter.
Oh, nice. Okay, but Bartolomeo, thank you so much for joining the session, and thanks to all the viewers who commented and asked questions. That's always great. And I hope to see you again. Bartolomeo, you have the last word here today.
Oh, I won't say thank you for passion to all, and I try to transfer what is the meaning behind LangGraph, behind this work, and happy AI coding to everyone. It's very hard, more than the image.
Amazing. Okay, thank you very much, and have a good day. Bye.
Bye.